Okay, so we're going to look at our last section of Unit 7, which is looking at improper integrals, which are integrals that either end at infinity or start at negative infinity. Alright. Okay, so if I look at our first definition, the integral from a to infinity of f of x dx, we would rewrite that as the limit as t approaches infinity of the integral from a to t f of x dx, and evaluate the integral that way. For negative infinity, from negative infinity to b, the integral from negative infinity to b of f of x dx, that's equal to the limit as t approaches negative infinity of the integral from t to b f of x dx. And the two other things we need to know is that if the limit exists, we call it convergent. If the limit does not exist, we call it divergent. Alright, so let's start with example 1. I'm going to integrate from 1 to infinity 1 over x squared dx. First thing I'm going to do is rewrite this as the integral of a limit. So the limit as t approaches infinity from 1 to t. And I'm going to rewrite 1 over x squared as x to the negative 2 dx. If I integrate x to the negative 2, I get x to the negative 1 over negative 1. Which I can rewrite as negative 1 over x from t to 1. Okay, so if I start by plugging things in, I get negative 1 over t minus negative 1 over 1, where t is still equal to negative infinity. So then in plugging that in, I get negative 1 over infinity plus 1, because 1 over 1 is just 1. Anyone know what negative 1 over infinity is? 0, right? Because as your denominator gets bigger and bigger, your numerator stays 1, so it approaches 0. So I end up with 0 plus 1, and 0 plus 1 is 1. Okay, let's do another one like that. Okay, so example 2, the integral from 1 to infinity of 1 over x dx. So I'm going to rewrite this as the limit as t approaches infinity from 1 to t of 1 over x dx. Okay, who can tell me what the integral of 1 over x is? Natural log. So this becomes the natural log of x from t to 1. So I'm plugging in my limits. I get the natural log of t minus the natural log of 1, where t is still approaching infinity. So this is like the natural log of infinity minus the natural log of 1. Anyone know what happens to your natural log function as it approaches infinity? Okay. Okay, so that tells me that the natural log of x is infinity. What's the natural log of 1?
0.
0. Infinity minus 0 is just infinity. So we would call this a divergent integral because it just goes towards infinity. It doesn't exist. Okay, so any questions on 2? Pretty straightforward. Let's look at example 3. And given the integral from negative infinity to 0 of x e to the x dx. First thing I'm going to do is rewrite it as the limit as t approaches negative infinity of t to 0, x e to the x dx. Anybody have any suggestions for how to integrate that function? Integration by parts. Yeah, so we're going to integrate it by parts. So I'm going to let f of x be x, g prime of x be e to the x. Alright, so what is the derivative of x? 1. What is the integral of e to the x? E to the x. So if I want to integrate by parts, I have f of x, g of x, minus the integral g of x, f prime of x dx. And I'm still going to evaluate that from t to 0 and from t to 0. Alright, so plugging stuff in, f of x is x, g of x is e to the x. G of x is e to the x, f of x is 1. E to the x times 1 is just e to the x. So I just have just the integral from e to the x. And what is the integral of e to the x? E to the x. So I'm still evaluating all of that from 0 to t. So I'm plugging that stuff in. I get 0 e to the 0 minus e to the 0 minus t e to the t plus e to the t. And t is still approaching negative infinity. Alright, so let's start simplifying what we know. 0 times e to the 0 is just 0. What is e to the 0? 1. Okay, if I keep going then, this is like negative infinity e to the negative infinity. So what is e to the negative infinity? 0. So this becomes 0 plus e to the negative infinity, which is equal to 0. So I get 0 minus 1 minus 0 plus 0. And what does that equal? Negative 1. So this, we would say, is a convergent integral because it does exist. It equals negative 1. Alright, one more. The integral from negative infinity to infinity of 1 divided by 1 plus x squared dx. When you have two two different infinity limits, two different improper integrals. You have to split it into two different integrals. So I'm going to go from negative infinity to 0, and from 0 to infinity. I'm still covering then from negative infinity to infinity, but I'm looking at it in two separate ways. Okay, so then if I rewrite it using my limits, the limit as t approaches negative infinity from t to 0 of 1 over 1 plus x squared dx plus the limit as t approaches positive infinity from 0 to t 1 over 1 plus x squared dx. Okay, so let's start by integrating. This is one of your integral identities from your integration notes. So figure out which one that integrates to become. So since our a in this case is 1, this just integrates to become the inverse tangent of x from 0 to t plus same integral, inverse tangent of x from t to 0. But in this integral, we have negative infinity. In this integral, we have positive infinity. Okay. So if I start plugging that stuff in, I get the inverse tangent of 0 minus the inverse tangent of t, which is negative infinity, plus the inverse tangent of positive infinity minus the inverse tangent of 0. Okay, so we should be able to do inverse tangent on your calculator. So inverse tangent of 0, 0. Okay, I'm going to guess that nobody really knows what the inverse tangent of negative infinity is. So go ahead and graph the inverse tangent of x function on your graphing calculator. Okay, so negative 1.47. It's approximately approaching negative 1.47. If I do the same thing then and I'm looking in the positive infinity direction of my inverse tangent graph, I'm going to get positive 1.47 because the graph is just a rotation if you flip it around the origin. And inverse tangent of 0, Jenna told us, was 0. Okay, so let's simplify. Minus negative becomes a positive. So I've got 0 plus 1.47 plus 1.47 minus 0, which gives me, anybody? Anybody? .94. So I'm approximately approaching 2.94. I actually think if we zoom out farther that your graph approximately approaches pi, which is 3.14, but 2.94 and 3.14 are pretty close. So 2.94 would be a good approximation of your limits. Okay. So you guys are going to work on this today and tomorrow, 551, 5 through 24.